Hi again. Let's talk about heart block, which is also known as AV block. And it comes in three types, 3 degrees. So, all of the types of heart block are problems with the electrical signals getting through that conduction system. So it's a blockage of the electrical signals getting from the AV node through the bundle of His, or from the SA node to the AV node, anywhere along that conduction system. First degree heart block is described, they get worse from first degree to third degree. First degree is simply an excessive delay getting past the AV node. So that was from the signal fires from the SA node to the AV node, and then there's a pause before it goes through the bundle of His into the ventricles. And we measure that by the PR interval, and that's longer than 0.2 seconds. So at this point, do you remember what the normal range is for the PR interval? It's time, minimum, maximum. So if you said 0.16 to 0.2 seconds, you're correct. That's the normal range. So if we have first degree heart block, it's great that PR interval is greater than 0.2 seconds. Second degree heart block, it's getting a little more serious. This is where not every P wave is followed by QRS. Normally, you remember you have P, QRS, and then T. In second degree heart block, sometimes you have a P wave, but it's not followed by a QRS. So the ventricular contractions are skipped. And they generally occur in some sort of repeating pattern, such as, for example, maybe 3 normal beats and then a skip. But there are various subtypes of second degree heart block defined by that pattern. I'm not going to worry about the different subtypes of second degree heart block. I'll show you examples that you should be able to recognize. Third degree heart block, the problems are quite severe in that conduction system, and there's been a total breakdown between the SA node, the atria contracting, and the ventricles contracting. So with third degree heart block, there's no coordination between the atria and the ventricles. All of that conductive tissue that we talked about is autorhythmic. And the SA node is the fastest. And that's what normally sets the heart rate, is the fastest component of that conduction system. And the SA node, move this box out of the way, normally sets the pace at about 100 beats per minute. Now that's slowed by the parasympathetic nervous system that we'll look at eventually. So it's approximately 100 beats per minute. That's the intrinsic rate of the SA node. The AV node, in comparison, beats at a slower rate, but it also is autorhythmic. So the AV node is slower. If it has to set the pace, it can do it, but it runs at about 50 beats per minute. So if you remove the SA node from the picture, the ventricles will beat at about 50 beats as set by the AV node. But again, normally the SA node is the fastest, and that sets the tempo for everybody else. Okay, so we're going to go through the 3 degrees of heart block. And this is first degree heart block. Remember what the definition of first degree heart block is. It's a excessive delay getting past the AV node. So again, the normal range of the PR interval, you can write that on your paper while I write it so you remember. It's 0.16 to 0.2 seconds. And so how many squares is that? Small squares. Well, we already worked this out. 0.16 seconds is equal to 4 small squares. And 0.2 seconds is equal to 5 small squares. So you just need to count up the squares in that PR interval. So let's do that on this tracing below. So this is nice and easy because the PR, or the P wave, so let's take this first one on the diagram over here on the left. The P wave starts right on a large square. If I can draw a straight line, so that's the start. There are 5 little squares, and we go to the top of the T wave, and oh, I don't know, it looks like it's about there-ish. So how many small squares? I'm counting 7. So again, just to work the unit conversion problem that I want you to be able to do, we have 7 small squares, and we're going to convert this to time. So we multiply it by the amount of time for each small square. So we said that 1 small square was equal to how much time? That's supposed to be a Q. 0.04 seconds. Make sure you keep the units with all the numbers, either squares or seconds or milliseconds, whatever the case is. So squares cancel out, and we're left with 7 times 0.04, and that comes out to 0. My marker here all of a sudden. 0.28 seconds. So you look at the ECG tracing, and you notice that that PR interval is longer than normal, and so this would be indicative of first-degree heart block. The other thing to notice about the EKG is it looks pretty good otherwise. The R waves are at regular intervals. All of the other waves are present and recognizable. So this looks like a sinus rhythm. So you probably describe this as sinus rhythm with first-degree heart block. Next slide is an example of second-degree heart block. And remember that second-degree heart block, not every P wave is followed by a QRS. So you just take a quick glance at the EKG, and it's pretty striking that you see groups of 2 R's present, and then there's a space, and then R, and R that doesn't look normal. So then you start taking a look at it in a little more detail, trying to figure out what's present and what's missing. Well, you know that the first wave is always a P wave. You have a P and then a QRS, and then after a QRS has to come a T, because the ventricles have to relax. If they don't relax, it's not going to pump blood, and we won't have an EKG. It'll be a flat line. So another cardiac cycle. After the T, you know it has to be a P. Atria contract, then the R, the ventricles contract, and then it's T, the ventricles relax. And then we go to the next bump, wave, which would have to be a P. And then, oops, there's nothing left. There's nothing after the P. There is no QRS at this spot. And then the next wave is another P, then R, and a T. Same thing, a P, R, T, and it would repeat. So there's no QRS here. And so what is this wave here? Make that into a question mark. Well, backing up a little bit, if this is the R, then you know this has to be a T, so that has to be a P. So, not every P wave is followed by a QRS. So, second degree heart block. Try to recognize those patterns. Third degree heart block. This is where, these are harder to interpret. I will ask you to be able to identify first degree and second degree if I gave you an EKG tracing. Third degree is a little trickier. I'd probably have to do some labeling, as in this example. There are two EKG tracings here. Both of those are third degree. So, again, third degree heart block is a complete block between the SA and the AV nodes. There is no coordination between the atria and the ventricles. And as I mentioned earlier, the AV node is also autorhythmic and is going at approximately 50 beats per minute. And the atria are faster. So, this one has already been labeled for you, which makes it easy because these can be very tricky, and you probably wouldn't be diagnosing third degree heart block unless the EKG machine auto-analyzed it for you. But what they've shown are the P's. They've gone ahead and labeled these for you. And another P. So the reds are all P's. And somewhere in there is a P. And then they labeled the T waves, or excuse me, the QRS. So there's a QRS, another QRS, and a third one. So the atria are beating along with every red P, and the QRSs are beating at a much slower rate, 3 in this short strip, compared to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 atria contractions. And similarly, this is another picture of third degree heart block. And I will not be asking you to identify and distinguish between the P's and the T's. If I gave you a picture like that, it might be extra credit. They are difficult to determine. So, I hope you learned a little bit about heart block, or it's sometimes called AV block, atrioventricular block. Again, it's a blockage in the electrical conduction system of the heart. It comes in 3 degrees, so practice these EKGs. See if you can recognize the heart block and get in the habit of calculating the PR interval if it's appropriate. We'll see you next time.